Okay, we're here again. Oof, good day, everyone. It's nice to have you in my channel once again. Quickly, I just said let's do a little introduction to this topic, mass volume relationship, as some of my students are asking for lectures on this. So basically, before we go into some few examples in the calculation, there are just some main terms you need to know their meaning. Okay, example of such is we have the mole and we have molar mass. Okay, so when you hear the word mole is simply the standard unit for measuring the amount of substances. Just like if a market woman should go to the market to buy gari, she would say, I want to buy 2 baskets of gari. But then in chemistry, chemists measure the amount of chemical species using the units called mole. So when you hear the word mole, to a layman, what should literally come to your mind, you can think of it like a dozen or 1 basket. It's just a unit for measuring the amount of substances. Okay? So, and then molar mass now refers to the weight of 1 mole of a substance expressed in grams. Okay? For instance, you have 1 basket of gari. If you should put that 1 basket of gari in a scale, the weight that would be read by that scale is the molar mass of that gari in quotes, just for illustration. So molar mass is simply the weight of 1 mole of a substance expressed in grams. For instance, we all know that the formula of sodium chloride is NaCl. Okay, so 1 mole of sodium chloride, the weight of 1 mole of this compound is what's called the molar mass of sodium chloride. So if you are to calculate the molar mass of sodium chloride, you simply add up the atomic masses of the elements that make up this compound. So we all know that sodium has an atomic mass of 23. Most of these numbers will always be given to you in your external exams in brackets at the end of the question. Okay, you have chlorine to be 35.5. So if I should ask you for the molar mass of sodium chloride, the molar mass of sodium chloride simply becomes the atomic mass of sodium is 23, then plus the atomic mass of chlorine is 35.5. So when you punch that in your calculator, that would give you about what? 58.5 grams per mole. So the unit for molar mass is grams per mole. So having known the meaning of these terms now, the next thing I would want to introduce you to is the principle I would be using in solving problems regarding mass volume relationship, especially problems that have to do with equations. All right. So if you should have, for example, 2 moles of, say, substance A reacting with, let's say, 3 moles of substance B, to give you, for instance, let's say 5 moles of substance C. Now, in most of these JAM and WAEC problems, calculations will be asked based on the amount of 2 of the species in the balanced equation of reaction. Okay, so for instance, they can ask you, if I should ask you, what is the mole of B needed to react with, let's say, 4 moles of A? You understand that question? I repeat, if I should relate A and B, and then the question is asking you what is the mole of B needed to react with 2 moles of A. The first thing you should do in such question is identify the chemical species referred to in the question. So I've identified them, A and B. Then you state what we call the stoichiometry that you would be using. Stoichiometry is simply the relationship that exists between, the quantitative relationship that exists between the amount of reactants or the product. So from the stoichiometry now, I can simply say from the equation above, okay, we can see that what? 2 moles of A reacted with 3 moles of B. Okay, so the question is asking you, for instance, what would be the moles of A, so let's say X, that would be needed to react with, for instance, let's just say 6 moles of B. Yes. So this is how you arrange your setup. This is synonymous to the mathematics we usually solve in our basic primary schools, where they would say, for instance, if 5 biro costs, let's say, 100 naira, what would be the cost of, let's say, 10 biros? Okay, so you say the cost is X. The same arrangement. So from here, you were taught that you should cross multiply from here, meaning at the end of the day, 5 would multiply X to give you 5X, then 10 multiplies this to give you 100. So by the time you divide both sides, X becomes 100 divided by 5 naira, which would give you 20 naira. Okay. Oh, sorry, I think there's a mix up there. If we should cross multiply, we have 5 times x and we have 10 multiply 100. This would go and multiply this. Then by the time you divide both sides, you have 10 times 100, then divided by 5. 5 will go into here to give you 2, and then 2 times 100 will give you 200 naira. Okay, so the same way we solve this, we'll apply the same logic here. So if you should multiply, this would multiply this, and then this multiplies this. You are going to have that what? X at the end of the day would be equal to 2. We go and multiply 6, cross multiply, okay? Then if x goes and multiply 3, you divide both sides by the coefficient. So you have divided by 3. You put your units, this is moles. We're looking for the moles of that. So your final answer, 3 here will give you 1, 3 here will give you 2. So 2 times 2 gives you what? 4 moles. So if you understand this basic concept, there is no problem given to you that you wouldn't be able to tackle. The only thing you need to know is that you need to state your stoichiometry. We have different type of problems. This question is a mole to mole problem, meaning for both of the species mentioned in the question, the examiner was concerned about the moles of the substances. Sometimes it can be mass. Somebody will say calculate the mass of this that is required to react with this or that is needed to produce this. So regardless, anyhow the question is expressed, I'm going to teach you how you translate the problem and then how you're going to solve it with the following examples we're going to look into. All right, let's get right into it now. Okay, so I just needed to clear off the board. Now let's look at something. There are some things you should know before we start calculations. So we have 1 mole of a substance. So we have said 1 mole of a substance, the weight of 1 mole of a substance is known as the what now? The molar mass of that substance. Okay, now you should also know that 1 mole of every substance contains Avogadro's number of elementary particles. By elementary particles, we mean atoms, molecules, or ions. So 1 mole of every substance contains 6.02 times 10 raised to the power 23 particles. Okay, the particles can be atoms, molecules, or ions. Now for gases, 1 mole of every gas at standard temperature and pressure occupies a volume of 22.4 dm cube, or if you multiply that by 1000, that's 22,400 cm cube at STP. So this is for a gas, okay? For 1 mole of every gas, this is the volume. Okay, 1 mole of every substance have Avogadro's number of particles. The weight of 1 mole of every substance is known as the molar mass. So from this, I can derive a formula that would help us in some questions as time proceeds. So mole, you should know that the formula for mole can be expressed as what? This is mass, okay? So if we take the mass of a substance and we divide it by the molar mass, that gives us the mole that we're considering in the reaction. Also, this is particles, right? So I can say number of particles divided by your Avogadro's number, 6.02 times 10 raised to the power 23. That's your Avogadro's number, okay? And then we can also express it in terms of this now. So we can say mole is equal to, this is volume. Sometimes you'll be given the volume. This is volume, then divided by molar volume. Molar volume we mean is 22.4 dm cube. Now, these formulas come handy for problems that do not involve reactions or equation. We're going to solve problems like that later. So they come in, especially for problems of such nature. But then this mole equal to mass over molar mass can come in when we are solving calculations involving reactions. So that said, now I think we're good to go into our calculations. All right. Okay, so let's look at this first example here pretty fast. Let's say consider the reaction represented by the equation. We're given a reaction, and then the question is, what is the mass? So be taking note of these key terms, okay? What is the mass of sodium triazocarbonate 4? So I told you to always pay attention to the chemical species mentioned in the question. So they mentioned this particular compound, this sodium triazocarbonate 4. What is the mass of sodium triazocarbonate 4 produced by the complete decomposition of, take note of this, 33.6 grams. Grams refers to the unit for mass. Grams of sodium hydrogen triazocarbonate 4. So your first step, sodium hydrogen triazocarbonate 4, this is the compound they're referring to. So your first step in every question in your JAM exam that is a reaction like this is to identify the two chemical species mentioned in the question, okay? So for this, they are relating the amount of sodium triazocarbonate 4 and the amount of sodium hydrogen triazocarbonate 4. So after identifying, you take note of the nature of the question. The nature of this question is a mass to mass problem. What do I mean by mass to mass problem? For this particular compound, you're asking for the mass, and then for this second compound, they gave us the mass also. So this is a mass to mass problem. Okay, so since we have specified that this is a mass to mass problem, the next thing I would do is to say from the equation, okay, we can see that we have 2 moles of this compound, okay, producing 1 mole of this compound. And remember, the weight for 1 mole of a compound is the molar mass, and the molar mass for both compounds are already given. So for this we have 84, for this we have 106. So this represents the mass or the weight for 1 mole of the compounds. So since I have 2 moles of this, common sense should tell us that we should multiply this number by 2. It's just like if I tell you 1 basket of gari is weighing, let's say, 20 kg. So 2 baskets of gari will weigh how many kg? You simply multiply 2 times 20 kg. The same thing now. So from the equation, I can say 2 times 84 grams of NaHCO3 produced 1 mole of this. And the mass for 1 mole of this is 106 grams. Since we have just 1 mole, we are not multiplying with any number, or you can say you're multiplying by 1. So 1 times 106 is 106. So produce 106 grams of Na2CO3. So the question is now asking us to calculate the mass of sodium triazocarbonate 4 produced by the complete decomposition of this. So you come down and say 33.6 grams of NaHCO3 would produce X, like I've explained previously. So from there, I told you cross multiply and you make X alone. So at the end of the day, we're going to have that X would be equal to 33.6. We go and multiply 106. Just exchange them. Cross multiply, you have 33.6 multiplying 106. Now, X would go and multiply 2 times 84. Later, you have to divide both sides by that coefficient, which is 2 times 84. So if I divide both sides by 2 times 84, I'm going to have my answer for X. So calculator now, we're going to punch this multiplied by this, we're going to have what?
3561.6.
3561 point what?
6.
0.6 divided by punch 2 times 84.
168.
We have 168 grams. So finally our answer becomes what when you divide those?
21.2.
21 point what now?
2.
0.2 grams. It's as simple as that. So whenever they give you a question like this is just the procedure you follow. Step 1, identify the two species. Step 2, identify the nature of the problem. This is a mass to mass problem. So you can see both sides of my stoichiometry are being expressed in grams. Sometimes it can be mass to volume. Sometimes it can be mole to mass. Regardless of regardless of anyhow the question is being structured, it's the same procedure. So for this video not to be too long, we're going to cut it here. But in subsequent videos, in my next video, we're going to be solving more problems on mass volume relationship. Please ensure to like, to subscribe to this channel to support the growth of the channel, and also comment. If you have any problem on mass volume relationship that's giving you issues, please drop it on the comment section. I'll see you in my next class. Thank you very much for watching.